Hi there. Now if you've been watching the previous videos where we went through parts A and B of this question, you'd know then that we're given this curve C where P has coordinates r, phi, and at this point here the tangent was parallel to the initial line. And the curve C had equation r equals a sine 2 theta, which is all summarised up here. And in the first part of the question, we had to show that cos of phi equaled 1 over root 3. And we're now told that the region S, shown here in the figure, is bounded by the curve C and the half line L. And we've got to use calculus to show that the exact area of S is given by 1/36 of a squared, all multiplied with 9 times the arc cos of 1 over root 3 and then plus root 2. And this is worth 7 marks. So if you'd like to have a go at this, just give you a moment then to pause the video. When you come back, you might want to fast forward just to get a quick picture of how I do it, or I'll take you slowly through the work solution. Okay, welcome back then if you had a go. Now in order to show you the working here, I'm going to need a lot more space. So what I'm going to do is we'll just take out a lot of this writing and essentially we'll just write down the question in brief. We're told that the cosine of phi equaled 1 over root 3, and we've got to show that the exact area of S then is given by this expression here. Okay, so how do we get then the area enclosed in this region here? Well, we should be familiar with the fact that when you're dealing with polar curves, the area, in this case S, is equal to the general formula, which is a half times the integral of r squared integrated with respect to theta. And for this example, we're integrating from the initial line here where theta equals 0 all the way round to this point here where theta equals phi. So we're going from 0 for theta to the angle phi. So if we substitute our values in then for r, okay, we've got half then times the integral going from 0 to phi. For r squared, r, remember, was equal to a sine 2 theta, so if we square that we're going to get a squared sine squared 2 theta integrated with respect to theta. Now when it comes to integrating something like sine squared 2 theta, sine squared of any angle, remember we go from the double angle identity, let's just write it down, cosine of 2a say, which is identical to 1 minus 2 sine squared a. If we rearrange this, sine squared a would be equal to a half of 1 minus cos 2a. So if we use that substitution and take the a squared out with the half, we get a squared then over 2. Then the integral from 0 to phi of sine squared 2 theta, which under that rearrangement where a is 2 theta, we're going to get a half of 1 minus cos of twice angle a being 2 theta, that's going to give us 4 theta. And we're integrating that with respect to theta. Okay, so we're using, let's just put from here, from this identity then we end up with this in here. Okay, now it's just a question then of integrating this. So we'll have the area of S is equal to, well, if I take the half out now, we're going to have a squared over 4, a squared over 4, and then we can integrate the 1 with respect to theta, that's going to be theta. Integrating minus cos 4 theta with respect to theta is going to be minus a quarter sine 4 theta. And that's going then between the limits of 0 to phi. And what have we got now? Let's just put the a squared over 4 out the front here. If we substitute our limits in, starting with phi, then we've got phi minus a quarter sine of 4 phi. And then substitute the 0 in. We're going to have 0 here, and the sine of 0 is 0. So basically we're going to be taking away from this 0. I'll just put that in as a token then, just to show that I've actually passed through that step. Now, we've got sine of 4 phi in here, and if I'm to give the exact area, I've got to break this down to sine phi's and cos phi's, because I can work off this fact here that cos of phi equals 1 over root 3. So I can pick up on the double angle formula, sine 2a is 2 sine a cos a here, where a would be 2 phi. So what we've got then is this is equal to a squared over 4 multiplied by phi, and then we'll have minus a quarter. Expanding this then using the double angle formula is going to give us 2 sine of 2 phi times the cosine of 2 phi. And we'll forget about the 0 now, so it just takes us to the end there. Now I can cancel out the 2 into that 4 there, goes 2. So we've got a half now at the front here. Still got to work on breaking this up into sine phi's and cos phi's. So we'll tackle that next. We've got a squared over the 4 then, and we'll have a square bracket there. We've got the phi, and we've now got minus 1/2 here, multiplied by the expansion now of sine 2 phi, which is 2 sine phi cos phi. Now for the cosine of 2 phi, I've got several options here. I've got either I could write cos squared phi minus sine squared phi, or I could write 2 cos squared phi minus 1, or 1 minus 2 sine squared phi. It's up to you. Okay, I'm going to go for 2 cos squared phi minus 1. And that takes us to the end there. So I've got sine phi here. Remember, we can get sine phi very easily just by considering a triangle. Right angle triangle, we know phi is an acute angle. Let's just mark it in here. And cos of phi is 1 over root 3, so that side is 1, the adjacent side. The hypotenuse is root 3, and by Pythagoras' theorem, this works out to be root 2. So sine phi is going to be root 2 over root 3. So we can substitute these values in here now. So we've got that this equals a squared over 4 multiplied with phi. And we can do some simplification here as well. This 2 here will cancel out with this 2 here. And so what we've got is minus, and then we've got sine phi, which is root 2 over root 3. So just put that in there as root 2 over root 3. And that's being multiplied with cos phi. Cos phi then is 1 over root 3. So we've got 1 over root 3. And then we multiply this with 2 times cos squared phi. So that's going to be 2 times the cos squared of phi. Cos of phi we know is 1 over root 3, so if you square that, that's going to be 1/3. And then we subtract that 1. So what we've got then is that this is equal to, in fact I'll come over here, I think we're going to need a bit more room actually. This is equal to a squared over 4 multiplied with phi. And here we've got 2/3 minus 1, so that's minus 1/3. So with this minus, that's going to give us a plus. And then we have got root 2 then times 1 times what would be minus a third in here. We're going to end up with root 2 on the top, and then on the bottom we're going to have root 3 times root 3, which is 3. We're going to have minus a third in here, so the 3 on the bottom gets multiplied with the other 3, giving us 9. Okay, so hope you can follow that bit. And what does this clean up to be? Well, we can pull out the 9 now out the front, so we end up with a squared over 4 times 9, which is 36. And then we'd have 9 phi. So 9 times phi. Phi is the inverse cos of 1 over root 3, or I could write that then as arc cos of 1 over root 3. And then we've got plus root 2. We don't need it over the 9 now because we pulled out the 9. So there we go. There's what we had to show.